Hey, welcome back to Math with Patrick. Today is September 12th, and we're solving problem 255 from the Daily Epsilon calendar. And as today is the 12th, the answer for this problem should also be 12. All right, we have a modular arithmetic problem in front of us. We need to figure out what 2025 to the power of 2025 is, mod 33. And let's talk a little bit about modular arithmetic just in general before we actually try this problem. Basically, modular arithmetic is like normal math, but you only have a limited amount of numbers and they cycle back on themselves. So if, for example, we are living in, say, the mod 6 universe, the only numbers we have are 1, 2, 3, 4, and 5, because the instant I tried to write a 6, it cycles back down to a 0. Another way to think about this is that we are essentially doing the modulo operator, where the modulo operator takes the remainder after division. So here I know that 6 divides 72 evenly, so the remainder after division is 0. And here I'm noticing that, not 6, but specifically 72 and 0 are considered the same under modular arithmetic. If I increment this up to a 73, the remainder would then be a 1, and then now 73 and 1 are considered the same in this kind of mod 6 universe. So with mod 33, we have 33 digits to work with. We have 0 through 32, and then once we hit 33, technically that's cycling back down to 0. So the first thing I'm noticing is that I'm not actually really allowed to have the number 2025 in my modular arithmetic system. Instead, I need to figure out what this number should be, and I need to figure out its remainder after division. And so I'll need to use this modulo operator and figure out what the remainder is. Maybe the best way to do it is through long division, I guess, because that is, one way to find the remainder after division. I can see that 33 does not go into 20, but it surely goes into 202. I think 6 is a good guess because I'm doing 6 times 3 in my head to get the 18, or I guess technically it would be 180. And so 6 times 33 is going to be the same thing as 18 plus 180, so 198. That looks actually perfect. Cool. Subtracting this, I get 45. Cool. 33 fits into 45 just the once. And it looks like my remainder here is 12. Cool. So the long division says that the quotient is 31. That doesn't really matter for modular arithmetic. The important part is that we have a remainder of 12. And so what I could say actually is that 2025 is congruent to 12 mod 33. And this just tells me I can replace that 2025 there with a 12. And now what I see is just we're multiplying 12 by itself over and over and over again, so many times. I think I'm allowed to replace this with a 12 as well. Although I'm not entirely sure, actually, if exponents also play that same game with modular arithmetic. I don't know off the top of my head. So for now, I won't change it. I'll keep it as a 2025. And here I want to see if there's some kind of pattern with my multiplication, because I don't really want to do 12 times itself 2025 times. Hopefully we can find some kind of pattern in the numbers. So let's just figure out what 12 squared is, mod 33. Normally, 12 squared is 144, but of course we can't do that in mod 33. And so we need to do the same division, figure out what the remainder is, and what's a good guess here? Maybe 4, because 5 would be 150, or more than 150. That's too big. So maybe 4 is going to be good. 33 times 4 is going to be 12 plus 120. That is going to be 132. Cool, that was a good guess. And then when we subtract this, we get 12 as a remainder. Oh, okay. So 144 is congruent to 12 mod 33. And it seems like if we keep multiplying each of these 12s, we're just going to get right back to 12 again. That's kind of neat that it's kind of stable, I suppose, that when we multiply 12 by 12, we get right back to where we started. So it doesn't actually matter what exponent we have on this 12. We're just going to get 12 every single time we multiply 12 by 12. So since 12 squared is the same thing as just 12 mod 3, 12 to the power of any power, let's just do, I don't know, b for the exponent, is still going to be 12 mod 33. So I guess there was no pattern here besides just that it hits 12 every single time. But essentially, this expression right here is just the number 12, which is today's date. So that's cool that the calendar is right and we do get 12 for today. And that's the whole problem. Well, hope you enjoyed the video. I'll see you tomorrow. Bye.